It's August 14th, 2017, and this is the K-12 Engineering Education Podcast. The oldest engineering discipline is civil engineering, and it's come a long way. My guest today is Jerel Rackley, a civil engineer at the design and consulting firm Atkins. Jerel spoke with me about what his team of engineers does today and about what young people might expect if they become civil engineers in the future. I met Jerel at the Atkins office in Austin, Texas. Jerel and I sat down at a long table in a bright meeting room surrounded by glass to talk. Welcome, Jerel Rackley.
Yes.
You are from Atkins, and what is Atkins, and can you explain a little bit about you and what you're doing here?
Absolutely. Atkins is a consulting firm. We do consulting in both design, engineering, and project management, and there's 18,000 employees globally. A lot of the Atkins work is in UK and European markets. But there's also a good amount that's in the United States. And I'm a civil engineer in the Austin office. We design roadways is primarily what I do. Different stages of roads, from the early concept planning through final design. And then also we help with some of the design-related tasks during construction.
How long have you been with Atkins doing civil engineering?
I've been with Atkins for almost 6 years and in the industry for almost 14.
And so just some background, I guess. So you are a civil engineer. What kind of education did you have to get where you are?
Yeah, so I went through high school, got kind of to senior year and thought probably doing some type of engineering would be interesting. I enjoyed math, enjoyed science, and so I went to Texas A&M as a civil engineering major. Didn't know for sure what exactly I would do. I knew some people that designed roads, kind of thought maybe that would be it. And it's probably my sophomore, junior year that decided that designing roads would be what I wanted to do. But graduated from A&M in 2002 and have been in the field since.
And you also are a PE. You've got a PE at the end of your name, professional engineer, right?
I do. And because we do engineering work on public projects, it's necessary that we have a PE, a professional engineer, sign the plans, do that engineering work, and then sign that they were responsible for that work. To get a PE, you typically have to have 4 years of experience and pass the PE test. It was important for the work that I did. So as soon as I hit 4 years, I took the test and became a PE.
Yeah, if people don't know what that is, like there's some teachers maybe who haven't ever really heard about the details of that. Is that something hard to do? Is it like an SAT test all over again? Or
it is, and it's mainly hard because you're out of the groove of doing classes and doing studying. So you've got these engineers that haven't really done much studying in a while, and we jump back into being prepared for a test. And so there's the prep and the PE test is probably a lot more than what most people do for SAT. Most engineers will spend probably 8 weekends getting ready for the PE test, really devoted weekends. There's a lot of PE prep classes. There's organizations that offer prep classes, and so we'll do those to get ready. So it's quite a bit of effort to take the test.
I asked Jerel what the different civil engineers in his group do, starting with what a new civil engineer could expect.
When you get into civil engineering, it's those first few years that are usually mostly design related, at least in the civil engineering that I do. We design roads. When a new engineer comes to our office, usually those first few years are sitting at a computer using our design packages, design tools on the computer to do the roadway design work. And those design tools are MicroStation. It's the CAD program that we use. And then there's a a program that runs within MicroStation called GeoPack that we use extensively. It's required by most of our clients. It's the industry standard. It's what we do. So those engineers will get to our office. They will grind away doing designs for 3 or 4 years. As they do that, they begin managing some tasks, doing a little bit more than just the straight up design, beginning to eventually manage projects.
And you said that you train them in the beginning. It's not like they just jump in and you expect them to know all this stuff.
That is correct. You know, we don't expect them to start at our office with much more than a great attitude. The problem-solving skills that come from being at the university for 4 years, the ability to work with other people. We want them to sit down with those things in hand. We would be great if they had some background, if they had spent some internships during their summers in college doing some design work. It'd be great if they had done some of that in high school with some engineering classes. But more than anything else, we expect them to get to our office and be ready to learn the specifics of how we do things. Usually what we do is pretty specific. And so almost everything is on the job training. It is, as far as that design related tasks. We teach them how to do those alignments for the new location out in the middle of nowhere. We teach them how to do those culvert designs. And we have a culture of mentorship and training from the other engineers, and we have senior designers in our office too. Folks that have been designing, that are not engineers, but have been designing for 15 or 20 years that are fantastic trainers. They can show every trick and most efficient way of doing things.
So it sounds like in the day in the life of an engineer, especially a newer one here, they would be doing a lot of design, some computer work. Mm-hmm. What's it like? What's this day in the life actually like? Yeah,
you know, if you looked around at our office, you'd see that probably 80% of an engineer's time, a young engineer's time, is spent at their desk doing design work. There is the other part of their time is spent with other engineers, either switching desks, looking over their shoulder, working on designs together. That training that we talked about. There's also a part of their day that's spent in meetings. We have usually weekly or maybe twice a week meetings with the project teams that are set up to make sure we're communicating and we're addressing the current state of projects and any issues and making sure we have a good direction forward. So it is a balance between those, but quite a bit of at the desk doing the design and calculations. You know, there's a lot of engineering calculations that we do that they're performing as well.
Yeah, sure. Then probably some of them are working on their PEs right now as well.
Yes. In our office, probably about a third of our engineers are EITs, engineers in training, which means before PE. So about a third are EITs, about a third are young PEs, 5 to 10 years, and about a third are older PEs.
What do you do then as a more experienced roadway engineer?
Yeah, my role is to manage projects, to manage the teams that are on those projects. My day is usually spent working with other folks on my team, working with the clients for our projects. Depending on the project, the breakdown of that time could be a lot different. I've been recently on design build projects where my whole day is at a project office. Most of us been in meetings coordinating with the contractor, coordinating with our team, planning the work ahead and addressing issues as they come up.
So you got to deal with a lot of people, is what it sounds like.
I spend 90% of my day working with people. I cherish the moments that I get to sit down and with my head at the computer and taking care of emails and other stuff. But most of my day is with folks, and it's I really enjoy that. It's fantastic. But it doesn't leave a lot of time for getting things done that I need to do as well.
Right. And you had mentioned before that you work with the public Why would an engineer need to work with the public?
Sure. We do projects that are for the public. So when we plan projects, we need to get the public's input. We need to understand their priorities. We also need to understand their view of impacts too. We can look at maps and do our investigations and studies and feel like we know the constraints in an area that would cause us to put a road here or there, but without going and talking to the people in that area, we don't know the full picture. They have a very unique perspective. And so we go and talk to communities as we're considering building a road in their area. And we, gain that information. We, understand the area, understand the project, understand the constraints better because we've talked to those people. 2, we inform. We let the community know what we're studying. We let them know how we're studying it and the things that we're considering, and then we work with them on what is the best alternatives for that community. So that's one reason, or one way we talk to the public. Another is as we have an active roadway project and we're building the road, we're impacting the community as we do it. We're affecting traffic. We're
sure all the construction stuff around. We see it in Austin all the time.
That's exactly right. And we have to inform them of what's coming up, what's going on. Again, we gather input too. We a lot of times will learn from the public that that detour that we did last week, we expected it to have maybe a 3 or 4 minute delay, and we heard from the public, well, actually, it was a 12-minute delay.
Yeah, I hear that.
So it helps us make decisions about how we progress our work to help us minimize that impact.
Yeah, because it sounds like a civil engineering company like Atkins and you as an engineer, there's a lot of responsibility then because thousands of people are affected by what you do.
Yeah, and it's the work we do has the potential to really impact a lot of people in a lot of different ways. What's exciting is most of it is very beneficial, and it's
Sure.
What makes me enjoy a lot of what we do is that we get to see those benefits, and that new road out in the middle of nowhere, it's providing the connections and the capacity that's for travel that's needed. It's fantastic, but it also has negative impacts too. There's a lot of good things that come with it, but there will always be negatives when you do something really good. And so we have to understand what those negative impacts are. It's a very large responsibility that we carry, that we're making decisions that are the best, that maximize those positive impacts and minimize the negatives.
Do you have to work with the government then as well to do what you need to do? Because you were talking about how, you make decisions on what a road might look like or where it's going to go, but like someone probably tells you to do that too, right?
Yeah, that's exactly right. And that's a great point is who our clients are. Being in the transportation industry, doing roads, a lot of our contracts are with TxDOT, the highway department here in Texas. A lot of what we do is for the local toll agencies. So here in Austin, it's the Central Texas Regional Mobility Authority. They're one of our clients. And then we do city and county work as well. So we have those folks that is that government entity that we do work with. And yes, they are very much a day-to-day partner with us in those decisions.
And then I guess the Texas Department of Transportation and all those other clients that you have, they must have civil engineers or engineers on their side too, right?
They do. And usually the project manager for the client is a professional engineer. There's times that it's somebody else that has the same kind of experience, but it is still able to do that management on the owner's side. But most of the time it is a professional engineer.
For for this podcast, I've already spoken to an electrical engineer, I've spoken to mechanical engineers and chemical engineers. I have not spoken with a civil engineer yet. Could you give a brief summary of what other types of civil engineers are there besides, say, someone who designs roads?
I wish I knew the breakdown of kind of the percentages.
Popularity.
Yeah, but transportation is a of course that's my perspective too, so it's probably pretty skewed, but it's
right?
yes, it's the best, and it's what everybody does. But that would be a large part of civil engineers is transportation. Mm-hmm. But land development, the development of neighborhoods is land development, and that's a large field for civil engineers. Vertical construction or buildings mm-hmm. is a large part of civil engineers do building construction. A lot of that is structural, the structural design for those buildings. There is water resources and water planning, so everything from water wells to other water sources. Civil engineers also do the drainage, addressing flooding issues and studying flooding and addressing it. Also, environmental. A lot of the environmental is related to water, doing some of that flooding, but also environmental cleanup. Civil engineers are involved in.
And if a teacher or maybe parents, if they've got kids who might be interested in engineering or they don't know if they're interested in engineering, what signs could they look for to see if, this kid might be a great civil engineer?
Yeah, most civil engineers, they enjoy math, they enjoy science, they enjoy those things. Probably be a pretty good indicators if that student would be a good civil engineer. What we talked about earlier too is kind of counterintuitive, but a great civil engineer is a great communicator too. Someone that works good with people and has those good social skills.
Yeah, some people wouldn't know that, right?
You wouldn't expect it from an engineer either. We think about engineers being kind of nerdy folks, and that often works well, and it's pretty okay to be very technical and not a great communicator, but it's definitely an asset for a civil engineer to be good at working well with other people, and so that would be something to look for in a student as well. But I would think, a lot of what probably affects how good we are at something is what we like and enjoy. And if a student had a real interest in building things and being a creator, then could be a sign that they would be a good civil engineer.
Creator who can talk to anybody would be really good. I'm getting the impression that maybe civil engineers, out of all the engineering professions, might be the more social because they have to be. They're forced to talk to all these people, whereas if I were just, I don't know, designing a small little part for a mechanical device, maybe I don't have to talk to as many people.
There may be some truth to that. I think so.
What's been your favorite project or favorite thing that you've done?
Yeah, I'll talk probably based on recent experience. We are building 183 South, which is a highway on the south side of Austin right now. And it's a project that I've gotten to be a part of from the planning. I was the design manager as we did the environmental studies, got to be a part of the team that did the final design. I was on the oversight team and was able to be a part of working with the public through all of that. And so and we're constructing that project now. The project is planned to be constructed in 2019 and 2020. And it's, to me, really exciting because we're seeing those plans that we've been working on for years come to fruition, and getting to be a part of it through all the stages has been personally very, very rewarding. It's neat to see that hard work getting built, and right now we're building the bridges and moving the dirt and doing those different components. It's happening, yeah, and it's great to see.
That's cool because you're working on this project that it sounds like it's taking longer than most people spend in school, I guess.
Yeah. I started on the project in 2012.
Wow.
And
right.
I would think that a lot of people that, hopefully if they started college in 2012, they would be graduated by now.
Because we're talking about kids who may become engineers down the road in several years, what kind of civil engineering technology will they be working on or working with? What do you see in the future of civil engineering?
Sure. In our field, we see slow changes usually, and there's maybe a software package makes some tweaks, but we're seeing some fast changes over the past year or so and coming up in the future. And a lot of it is integration of 3D tools in a very in a package that allows for changes very quickly. So in the past, we would, as we were doing a road, we would have an alignment and then a profile and then cross section, all these three things that were completely separate. Now we have new software it's a Bentley program called Open Roads that combines it all. And I'm certainly not the expert on it, but the folks in the office that are really excited about what it means to our industry, and that we'll lay out a road and put it in a 3D model. And then when we make changes, we make one little change, everything updates at once, and it's model driven.
So it makes design just much faster, is what it sounds like.
It does. It makes the initial design a little bit quicker and more intuitive. The best part is it makes those, we're always changing things, and it makes those changes a little bit simpler too. And as we do things in 3D models, it also gives us a really good communication tool. Today, there's times that we go to public meetings and we present things to the public. We create a 3D model, a 3D rendering, but there's a lot of effort required in it. Mm-hmm. With some of these new, with our CAD environment being in 3D, then it makes that conversion to a 3D rendering very easy. There's some tools within Open Roads, you push a button and you have a pretty good rendering that you could use as a communication tool to the public.
Okay, yeah. So I'm imagining, like in the past, maybe you had a bunch of 2D drawings or something, but now, like, you can quickly make a 3D rendering in any perspective that you want and do it pretty fast. Is that right?
That's right. And in the past, we would create 3D renderings out of it, but it would just take time and a lot of effort. And it was sometimes we didn't do it because the effort didn't justify the reward.
That's really neat. I'm waiting for the virtual reality people to work with you so they can just step right into your imagined road, and that would be really neat too.
That'd be great. You can take people out to a site and say, this is what this area looks like today. Yeah. Let's lay it over an augmented reality vision, and here's what it will be in 15 years.
What's some of the hardest things about being an engineer that someone should know before going into it?
I think, back to what we said earlier, that working with other people, that can be hard for engineers.
Maybe unexpected.
Yeah, and also it's sometimes hard to continue to find the drive day in and day out. If you get stuck in something that's rather monotonous, and there's some engineering tasks that are that way, that do the same thing over and over and over, and that can be hard.
To follow up with that, then how do you stay motivated? I mean, a kid, they I'm sure get impatient. How do you develop that skill of just doing what you got to do and getting the payoff? Yeah,
I think it's something that everybody probably develops differently or figures out. I know that it is something that's learned, that you just learn to keep on going, and you also develop relationships at work and friends that keep you going too, that you find times to take a break and go and enjoy the people around you. And that would probably be a tip that I would have for folks in the field, and for teachers, helping students understand that being technically proficient and having these skills is awesome, but when they start shopping for jobs someday, to really think and choose companies that are a good fit for them, that are doing the type of work they want to do, but also as a culture or a good fit, find the place that they enjoy to work.
Yeah, I think everybody is looking for that too, but that's good advice. Find good people, essentially.
And I don't know exactly how you do that. I think a lot of that is luck.
Maybe teachers know how to, maybe that's what they got to work on. Teachers will figure out how to teach their kids to do that.
Maybe so.
All right, well, Jerel Rackley, thank you so much. You are a civil engineer from Atkins, and I really appreciate you taking the time out to talk to me and to everyone listening.
Absolutely. Thank you.
Thank you also to several others at Atkins for helping arrange this talk. For links to some of the topics that Jerel mentioned today and for transcripts, visit the podcast website, k12engineering.net. Do me a favor and rate and review the show on iTunes or Stitcher. You can help others discover the podcast that way. Message the show on Twitter. You can tweet at K12Engineering or tweet me, your host, directly at Pios Wong, or you can leave a message on the show's Facebook page. Finally, you can financially support this show and the other projects of Pios Labs by donating on Patreon at www.patreon.com/Pios Labs. You should check out Bleep Tour on the internet because they wrote the closing music for this episode. The music is called Late for School, and Bleep Tour distributed it under a Creative Commons Attribution license, so thank you for that. The K-12 Engineering Education Podcast is a production of my independent studio, Pios Labs. You still have a few days left this August 2017 to vote for your favorite sessions for the upcoming South by Southwest Festival and Conference in 2018. And yours truly has submitted some sessions. So my colleagues and I submitted to the education conference part of South by Southwest. And if you go to panelpicker.sxsw.com, you can register and you can vote for our sessions. So again, go to panelpicker.sxsw.com and search for my name. You can search for my name, Pius, and our proposals, our session proposals will come up. One of them is related to this podcast. It's called Podcasting for Education Meetup. So if you like this podcast, I'm sure that you'll support the idea of podcasters collaborating to promote education. That's all I got to say. Go to panelpicker.sxsw.com and please vote for us. Thanks.